Hello everybody. Today we are learning a new topic, x and y intercepts. So an x-intercept is where the graph crosses the x-axis, which is the horizontal one, that means going left and right. And the y-intercept is where the graph crosses the y-axis, which goes up and down. You can see the x labeled here and the y labeled there, reminding you that this is the x-axis and this is the y-axis. So when you look at this graph, the x-intercept is, we want to find the place where it crosses the x-axis. That's right here. So my answer is x equals -4. The y-intercept now is where it crosses the y-axis, right there at 0, 6. So my y-intercept is y equals 6. These problems over here, the x-intercept, that's this axis, it crosses right here at 4. And the y-intercept, where it crosses the y-axis, that's right here at y equals 3. Okay, try to predict what this one is going to be. The x-intercept is 5, x equals 5. And the y-intercept is -4. So now we're going to get into the algebra of how to find x and y intercepts from equations. This page is actually just an example problem. There's no actual work for you to do here. So the way we find an x-intercept is by making y equal to 0 and solving for x. The reason why we do this is because whenever a graph crosses the x-axis, the y value of the ordered pair is always 0. So what we can do is we can just make y 0 in the equation and find out what x value gets you there. Okay, so here's how we do it. To get the x-intercept, we make y 0, so there's replacing 0 with y. Anything times 0 is 0, and then we divide by whatever the coefficient is. For the y-intercept, it's very similar. We make x 0, and then we solve for y. And once you get those values, you put the y-intercept on the y-axis and the x-intercept on the x-axis and draw the line. One kind of cool way of doing this is called the covering up method. So to find an x-intercept, what you can do is you can cover up the y value. Then you get 2x equals 8. If you divide both sides by 2, you get 4, which is the x-intercept. Same thing with y-intercept. You can cover up the x, and then you get 4y equals 8. Divide by 4, you get y equals 2, which is the y-intercept. All right, now for some actual problems here. The first one, 3x minus 2y equals 12. So for the x-intercept, I make y equal to 0. If I make y equal to 0, that would mean I have 3x minus 0 equals 12. Or 3x equals 12, and I have x equals 4. X equals 4 is along this axis right there. Using the cover-up method, it would have worked like this. We would have covered up that 2y there, and then we get 3x equals 12, and divide by 3. For the y-intercept now, I make x 0, so this whole thing becomes 0, and I have -2y equals 12, making y equal to -6. So I have y equals -6 right there. Now we take out a straight edge of some kind and draw a line that goes through those points, and we have graphed the line. Over here, x-intercept, if we get rid of that, we have x equals 6. And if we cover up the x, we get 2y equals 6, so y is equal to 3. And we plot that line. The slower math of that could be for the x-intercept, we get x plus 0 equals 6, so x equals 6. And if we make the x equals 0 for the y-intercept, we get 0 plus 2y equals 6. So divide by 2, and we get y equals 3. Moving on to the final problem here, the x-intercept. If I cover up the 5y, I get negative 2x equals 10. And divide by negative 2, I get x equals negative 5. If I cover up the negative 2x, I get 5y equals 10. Divide by 5, I get y equals 2. X equals negative 5 is right here on the x-axis, and y equals 2 is right there on the y-axis. Sketching the line. Oopsie. Oh, close enough. There it is. Email us if you have any questions.